Here in this video, we are solving questions that appeared in NEET 2023 from the chapter Alternate Currents, ACs. Let us solve the first question. In the series of LCR circuit, inductance, capacitance and resistance are given for us. The frequency at which its resonance occurs is, right? So to solve this, we shall go for the basics of that concept actually. What is that basics of that concept is? Let me tell you. 24th question. In a LCR circuit, so this is L, this is C, this is R. Connected to an AC source, this inductor offers some opposition called inductive reactance. Capacitors also some opposition to the flow of the current called capacitive reactance. Resistance offers opposition called resistance. Inductance and capacitance are having this opposition in opposite direction, and resistance is perpendicular to the resultant of both of them. That all together is called impedance. Impedance could be written like XL difference XC whole square plus R square. This means to say XL and XC are in opposite direction. Their resultant is perpendicular to resistance. For the circuit to be in resonance, for resonance to happen, Z has to be minimum. That is possible when XL equal to XC. When these two are equal, Z becomes square root of R square, R minimum. Current in the circuit is maximum. Then it is called resonance. So what is supposed to happen is XL equal to XC. XL means omega L. XC means 1 by omega C. See, omega square equal to 1 by LC. Omega equal to square root of LC. At omega is 2 pi n, where n is the frequency. We have to calculate that. Square root of L inductance is 10 milli, 10 into 10 power minus 3. And C capacitor is 1 micro, that is 1 into 10 power minus 6. Okay. So 2 pi n equal to 10 power minus 3 and minus 6 is minus 9 plus 10, that is minus 8. So in the numerator it becomes 10 power plus 8 under square root. That is 10 power 4. So frequency n equal to 10 power 4 divided by 2 pi. 10 power 4 means 10,000. 10,000 by 2 pi means 5,000 by pi. 5,000 by pi means, so if you calculate that, it becomes 1.59 into 10 power 3, that is kilohertz. So your answer is 1.59 kilohertz. That's the answer for that question number 24. After solving the 24, let us progress for the next question, that is question number 25. Let us see what this question says. 12 volt and 60 watt lamp is connected to a secondary step down transformer. So this is about a transformer. Transformer will first of all will have a primary part of a transformer and the secondary coil. Between them there is a core. Here the parameters are primary, here the parameters are secondary. We can say the power of the transformer is EMF of the transformer into current of the part of that coil, right? That is equal to E secondary and I secondary. Therefore I primary by I secondary can be further written as EMF secondary by EMF primary. From this they are reciprocal to each other. EMF is inversely directly proportional to number of the turns in the transformer coil, right? If the more turns are there is more EMF per coil per turn, therefore more turns means more EMF. Now we can calculate, let us see what is the data given for you. Secondary coil 12 volts and 60 watt. So I can calculate from that using a formula, power equal to VI. From that, from secondary coil power equal to Vi. Power is 60, V equal to 12 and I secondary, because that's all secondary. So I secondary is 60 by 12, that is equal to 5 amperes. Now I know I secondary, so I can substitute here. I primary by I secondary is 5, that is equal to, what we can say further is EMF secondary. EMF secondary is given for you in the problem as 12. EMF primary is further given in the problem as 220 volts. The primary is connected with 220 volts. What is the I primary is the question. Now we can solve this further as 5 4s are 20, 5 4s are 20. So I primary is 44 by 44. So I think I have missed it. 44. Let me cross check with the calculation. I primary into 44 is equal to 12. Then I primary equal to 12 by 44, that is 6 by 22. So when you calculate this value, it comes approximately 0.27 amperes. That's the answer for this next question 25. There is one more question given in the exam on the same year from the same chapter. Surprising, The net impedance of the circuit is how much? This is the formula, actually we have already discussed it. I can just try to use it, right? So net impedance of that is root of XL is omega L, whereas omega means let us substitute the data here. XL means actually omega L, XC means 1 by omega C whole square plus R square, where omega equal to 2 pi into N. Frequency is given as 100, 2 pi into 50, that equal to 100 pi. Let us substitute the data now. Square root of omega means, as I have calculated, 100 pi. L means 50 by pi milli, that is 10 power minus 3, that much is there, minus 1 by omega C. Omega again 2 pi N, that is 100 pi as we have calculated. C is given for you as 10 cube by pi into 10 power minus 6. Whole square is there, plus R square. R square is 10 square. Let us calculate this further. Here pi gets cancels, here also pi gets cancels. 100 into 50, that is 5000 into 10 power minus 3. So what is remaining here is 5 minus 10 power 2 and 10 power 3, 10 power 5 and 10 power minus 6. So 10 power minus 1 in the denominator becomes 10 power plus 1 in the numerator. Whole square plus 10 square. 5 minus 10 is minus 5, minus 5 whole square is 25, 10 square is 100, 125. Square root of 125 can be written like 5 root 5. That's the ohms. That's the answer for the problem. That's how we solve the problem, right? So they all depends on one simple concept like impedance of the LCR circuit, and you also need to know the concept of transformers, that efficient transformer power input equal to power output. These two are the things that we have used to solve this problem. Thank you for watching.